Hi, and welcome back. I want to point out another pitfall of using default values in function parameters, and in particular when we're looking at mutable values. So this is something that's pretty easy to fall into, and let me show you what I mean. Let's start by saying that we want to create a function that's going to add grocery items to a list. And we'll provide the list to the function, so that's a mutable type, and then we'll provide information like the name of the item, the quantity, and the units, let's say, of the items. So let's go ahead and write that kind of function. Let's call it add item, and we're going to provide it a name. We're going to provide it a quantity, and we're going to provide it the unit, and we're also going to provide it the grocery list. And what we'll do is that we'll append essentially in a uniform way the item to the grocery list. So let's go ahead and do that. So we'll say grocery list dot append, and we're just going to format this nicely. So we'll take the name, then we'll put in maybe the number of units, or the quantity, and then the units. Let's format it that way. So then we'll have format name, quantity, unit. So this will append it to the grocery list. Now technically we don't have to return the grocery list because it is a mutable type. It's being passed in to the function, and therefore we don't need to return it. In fact, that's a better approach. If you're going to mutate something that's getting passed into a function, a better approach is not to return it. This way the user, when they use the function, knows that something's going on. If they're not getting the list back, then they're going to have to realize that grocery list is being mutated. So that's a better approach than doing this. However, I want to do this, I have to do this because I want to point out a flaw in this kind of approach. Now, not this particular approach, but we'll make a slight modification to this in a minute and see how we get a problem. Okay, so we have this function. So let's say that I have two stores that I need to visit. So I'm going to want to create two grocery lists. Let's call it store 1 and store 2. Okay, so now we've got these two grocery lists, and I'm going to start adding items to my grocery list. So I'm going to say add item, and let's say we want to buy some bananas. We want to buy 2 bananas, and these are just going to be units, let's say 2 units of bananas. And we're going to add that in store 1. Then we're going to add another item. Let's say we want to buy some milk. We want to buy 1 liter of milk, let's say, and we'll go ahead and buy that in store 1 as well. Okay, so we now have our grocery list. Let's go ahead and print store 1. And you can see we have our banana and our milk. Okay, good enough. So now let's go ahead and start adding items to the second store. So let's say add item, and we're going to add, let's say, Python. Right? We're going to buy a Python. We're going to buy 1 Python, and what kind of unit? Well, we wanted medium rare. So let's go ahead and buy a Python, and let's just add 1 item to that list. And okay, sorry, we're missing the store that we want to add it to. So we want to add it to the list for store number 2. So now if we print store number 2, we see that we have 1 medium rare Python in that grocery list. Okay, so that's working out pretty good. But you notice what I had to do here. I had to first create my empty list and then pass it into the function. So let's go ahead and change this function and make it a little easier for our users. All right? We think that we want to make their life easier. So let's go ahead. I'm just going to take the same function. So copy paste. And here, what I'm going to do is that if they don't provide us an existing grocery list, I'm going to create a new one. Right? So instead of appending to the grocery list, I'm going to create a new one and then append to it. So what I'm going to do here is just start an empty list. Okay, a list, not a dictionary or a set. Okay, so now we have this empty grocery list. So let's go ahead and run our examples again. So I'm going to add these items. Okay, sorry. What I want to do first is I want to delete these two grocery lists. So I want to delete those things. So you'll notice now store 1 doesn't exist anymore. Okay. All right. So now let's go ahead and do that. Let's say store 1. So store 1 doesn't exist, but since I'm returning it from the function, and that's why I needed to return the list from the function, it's when it gets created, I need to somehow get a handle on that object back. So let's go ahead and just add the item as we did before. Let's go ahead and add this. So I'm just going to copy paste. I'm lazy. Okay, so we have that. And now what I can do is I can add item again to store 1. Now I don't have to assign it to store 1 anymore because store 1 is being mutated. So I can just keep doing that. Store 1 is not defined. Yeah, sorry. What we want to do here is not pass it in. Okay, so I apologize. So we don't want to pass it in. So it will get created. And now the second time around, store 1 has been created as a list, as a new list from add item. And we're going to use that to append. Okay, so now let's see what we have in store 1. And we have our banana and our milk. Okay, good enough. Now let's go ahead and do the same thing with our second store. Now we want to do store 2 equals add item, and we're going to add the Python that we want to purchase. But again, I'm not going to specify the list, so this will start a new list. Okay, and so now we've added our Python to store number 2. So let's go ahead and see what's in store number 2. And you'll notice we have a problem. We have the items from store 1 showing up in store 2. And what about store 1? What's going on? We've got the same items. Well, in fact, what you have is that store 1, the memory address of store 1 is the same as the memory address of store 2. They're both the same lists. Okay, so what's happening here is, let's go back to the function. Remember when this line of code runs. It runs, in this case, in the Jupyter Notebook, when I execute it, when I do the Shift-Enter to execute this cell, this function is created. In a regular Python program, when you load the module up that contains the function, at that point, that function will get created. And that is when the default parameter values are evaluated. They get evaluated once when the function is created. So every time I call this function add item, the default list has already been created. It was created once. So you got a single object, and every time I call add item, and even if I don't specify the grocery list, it's going to use the default. And that default will be the same no matter when I call add item. So when I called add item here with nothing for the grocery list, it used the default object, which was some memory address. When I called it again without using a list again, without passing in the grocery list, it went ahead and used the same list object. So we've got this shared, essentially, instance of the grocery list, right? That's always being used when we call add item. So that's a problem. In this case, we don't want this to happen. So how do we solve that? Well, it's very simple, and it's a standard pattern that we use. We use none. So do not use basically mutable default types in your function definitions unless you actually want to do that. And we'll see an example of where we might want to do something like that and actually leverage something like that in a few minutes. So the standard pattern is to do it this way. Use none for your default values. Now, of course, if you're using a non-mutable type, like an integer and so on, it's perfectly fine to set, let's say you want your unit default to be 1. That's perfectly okay. Because remember that this is not, we're not going to change the number of units. Here, the problem's happening because we're mutating grocery list. Since 1 here is non-mutable, it doesn't matter. Okay, so I'll leave that unit equals 1 in there. And so the pattern here is that we're going to say if not grocery list, in other words, if grocery list was not supplied, if it is none, because none, remember, will evaluate to false. Okay, the truth value of none is false. So if not grocery list, then we start a new grocery list. So we can do that. And now this will work because remember, this code will run every time the function is called. So every time the function is called without passing in the grocery list, it will then execute this. And of course, this is a different function scope each time. This will be a new object every time. So now, if we have this, we can now do the same thing that we did before. So I'm just going to copy paste. Okay, and so we have the list for store number 1. Let's go ahead and print that out. We have that. And then we have also the list for store number 2 that we can start creating, where we just do it this way. So now we've got store 2, and now we can print store 2, and you can see we have a different list. And in fact, store 1 is store 2 is false. They're not the same object. So that's the way that you can fix this problem. So be very careful when you use mutable default types in function parameters. It can really cause problems because you're using the same object. And when it's immutable, it doesn't matter because you can't change the contents of that object. But when you're working with a mutable type, it does matter, right? As we saw in this example here. Okay, let's take a look now at an example where we might actually want to leverage something like this. So let's go ahead and let's do a very simple factorial function. And we're going to use a recursive definition for it. So if n is less than 1, we're going to return 1. Else, we're going to print the fact that we're calculating n factorial. So we'll print that, and then we'll return n times factorial of n minus 1. Okay, so that's a very, very simple approach to calculating a factorial using a recursive approach. Not the most effective, but it works. Okay, so now how do we call it? Well, we just call it, like, let's say this way, factorial 3. And you'll notice that it's calculating 3 factorial. But in order to calculate 3 factorial, it also has to calculate 2 factorial. But in order to calculate 2 factorial, it has to calculate 1 factorial. And then 1 just returns 1. So you can see that to calculate 3 factorial, we had to calculate 3 factorial, 2 factorial, and 1 factorial. And finally, we got our answer of 6. So great. Now let's run it again with the same number. And you'll notice that it had to calculate again 3 factorial, 2 factorial, 1 factorial. So in other words, it had to redo those calculations once more. So now let's go ahead and do it a different way. Let's say that we want to cache those results. So what I'm going to do is I'm going to define another function, factorial. So I'm going to redefine this. And I'm going to make a, for starters, I'm going to do it this way. I'm going to make a keyword-only parameter. I'm going to make it mandatory, and that's going to be a dictionary. So in other words, we're going to have to create outside of the function. We're going to have to tell our user, when you use this factorial function, you have to create a cache variable, which is going to be an empty dictionary, and you need to pass it to us every time you use it. So that's probably not very user-friendly. So we'll want to fix that up. But for now, I just want to put it outside, and let's see how we would do it this way. So the factorial now takes this mandatory cache dictionary, and we have to make a few tweaks to this. So we're going to say if n is less than 1, return 1. Otherwise, we have to calculate the factorial, but what we're going to do is first check to see if that n value, that key, is in our cache. If it is, we're just going to return the value out of the cache that we've stored associated with that key. So we're going to say elif n in cache return cache n. If it's not, then we're going to have to calculate the factorial. So let's go ahead and calculate the factorial. Now, of course, it's not in the cache, so we want to add it to the cache. So now we're going to say cache n equals result. Okay. Now, the only other difference too here is that factorial requires cache, so we need to pass it the cache. Now, in this case, I made cache a keyword-only parameter, so I'm going to have to pass it as a keyword parameter, a keyword argument. So there we have cache equals cache. And then finally, we can now return our result. So here we have our factorial function. But what it means is, in order to call it, we have to first create this cache over here. Let me delete it from here because we actually don't need it to be defined to define the factorial function. But before we call it, we have to define that empty dictionary, our cache basically. And now we can call factorial. So we can say factorial of 3. Now we have to specify the cache, okay? And then we have calculating 3 factorial, 2 factorial, 1 factorial. Let's go ahead and run this again. Now, what's in the cache, by the way? We can print the cache, and you can see that we have 1 is 1, 2 is 2, and 3 is 6. So those items have been cached, right? 3 factorial has been cached. So if I call factorial of 3 again, you'll notice that we don't get any of the calculations. None of these lines of code were run. Okay, we ended up hitting the cache every time. Now, if we want to do cache 4 factorial, what's going to happen? Well, 4 is not in the cache, so it's going to get calculated. But the remaining ones, like 3 factorial, which it needed to calculate 4 factorial, wasn't called, right? We got those results directly out of the cache, and so on. So this is a really interesting technique, and we'll come back to this in more detail when we look at closures, and we'll see a better approach to this, really. But at this point, we can still fix this up quite a bit. This isn't very user-friendly. Every time we have to remember to pass, the cache in. We've got to tell the user, before you can call the factorial function, you need to pre-create a cache dictionary that you have to pass in every time. That's kind of a pain. It's not very good code. It's not easy to read. It's a pain. So let's fix that up by using this caveat that we just saw. So I'm not going to make this a keyword-only parameter. In fact, I'm going to make it an optional parameter, and I'm going to define the cache as a default value of an empty dictionary. So now look what happens. If I don't pass the cache in, it will create that one. And every time I call the factorial function, it's going to use the same dictionary. Just as we saw with the grocery list, it was using the same default grocery list. Here, we're going to use the same default dictionary. It's a mutable type. We're going to modify that default. So now, we don't even have to pass it in here. We're just going to say factorial n minus 1. Okay? And we're done. We've just fixed this up. So now, let's give it a try. Let's see factorial 3. You'll notice we recalculated 3 factorial, 2 factorial, 1 factorial. Well, sure, the cache is empty. We have to make all those calculations. But if we call that again, factorial 3, you'll notice that we just get the result 6 back. That was a cache hit, right? This line of code didn't execute. We never got into the else statement. We hit the cache value instead. And the same thing occurs if we try and do factorial 4. You'll notice that we calculate 4 factorial, but none of the other remaining ones in the recursion calls. So this is an example of how you can actually use to your advantage what's going on with the mutable default parameters. But be very careful with it. The other thing that I don't particularly like about this approach, it's that it's a little harder to understand than what we'll see when we do the memoization using decorators. And also by using decorators and closures, we get something that's a little more reusable. Here, we're kind of hard coding our cache into our function. There's a better approach to this, and we'll see that. But certainly this technique works. It's called memoization when we're caching these values, and it certainly works, and it can be very helpful. There just are better ways of doing it. All right, thanks for watching, and I'll see you in the next video.